Section 10.1. Our objective is I can simplify expressions with rational exponents. Before we can actually get started on the lesson, we need to remember what exponents mean. So remember 2 squared really means 2 times 2 or 4. Remember a negative exponent means the reciprocal. And so 2 to the negative 2 is really 1 over 2 squared, or 1 over 2 times 2, or 1/4. Also remember that anything to the 0 power is equal to 1. Then we had the rules for exponents. So the first rule, called the product rule, if you are multiplying and you have the same base, you keep the base and you add the exponents. The power rule, if you are raising a power to a power, then you keep the base and then you multiply the powers together. Okay? And then the quotient rule, when you have a base to a power divided by a base to a power, notice it has to be the same base. Then you subtract the exponents. Okay? So that's what we know so far about exponents. Today what we want to look at is what's called a rational exponent. A rational exponent is an exponent that has a fraction, or that is a fraction, I should say. So a rational, remember, rational means fraction or ratio. So a rational exponent would be something like, well, my base would be 2, and a rational exponent would be, for instance, 3/5. So that's 2 to the 3/5. Okay, so notice that the exponent is a rational number. Okay, now when the exponent is a rational number, the numerator means one thing, the denominator means another. So 2 to the 3/5. The numerator is the power. Okay? Just like on all our rules that we've done before. Okay? The denominator is the root. So remember, roots undo powers. Okay? So for instance, this could be written as 2 cubed to the 1/5, because by the power rule, if I multiply these two together, I get this. Okay? And the 3 tells you what power to raise it to. So that's 2 to the 3rd power, or 8. Okay? So we have 8 then to the 1/5. The denominator tells you what root to take. So that's telling me to take the 5th root. So the 5th root of 8 is the simplified answer. Okay? Now notice that we can, it doesn't matter what order we do it in. So for instance, if I have 4 to the 3/2, well, I could do 4 to the 1/2 cubed. Well, the 1/2 means square root, so that's the square root of 4 cubed. Square root of 4 is 2. 2 cubed is 8. Okay? Or I could do 4 cubed to the 1/2. Well, 4 cubed is 4 times 4 times 4, or 64 to the 1/2. The 1/2 means the square root, so square root of 64 equals 8. So notice that the order I do it in doesn't matter. So we want to do it in the order where it's easiest to simplify. So in general, the general rule is this: any base to a rational power is equal to the root of the base raised to the power, or it's equal to the base raised to the power and then the root. Okay, so let's look at some examples with numbers. So, number 1, I have 81 to the 3/2. Okay, well that's the same thing as 81 cubed to the 1/2, or I could do 81 to the 1/2 cubed. Which one is going to be easier to do? Think about it. Which one will be easier? Right, this one. That one's going to be easier to do because this one really says the square root of 81 cubed. Well, what's the square root of 81? It's 9. Okay? So 9 cubed is 9 times 9 times 9, or 729. Okay? So then, number 2. I have 8 to the negative 5/3. Okay? So, I could do that as 8 to the 5th raised to the negative 1/3. Or I could do that as 8 to the 1/3 raised to the negative 5. Which one will be easier? Think about which one would be easier to simplify. And it would be probably this one, because that one says the cube root of 8 raised to the negative 5. So the cube root of 8 is 2 to the negative 5. Remember that the negative part of the exponent means the reciprocal. So that's really 1 over 2 to the 5th, or 1 over 32. Okay, example 3. 9 to the 1.5. Now wait a minute. Is 1.5 a rational number? No, it's not a rational number. It's not written as a fraction. But could it be changed to a rational number? Because remember that this is really 9 and 1 and 1/2, which is really 9 and 3/2. Now it is a rational exponent. So now we can take the square root of 9 and cube it. Okay, so that's 3 cubed, or 27. Number 4. 1 over the cube root of 81 raised to the negative 3/4. Okay, well, let's go ahead and change this radical to an exponent. Okay, because we know if we go back up here, this radical came from a 1/2. Okay, so this as a radical is going to be a 1/3. Then, using the property of exponents, could I write that as 81 to the negative 1/3 raised to the negative 3/5? Okay, now using the properties of exponents, that's negative 1/3 times negative 3/5. These cancel, the negatives cancel, so it's 81 to the 1/5 power. Okay, so then written as a radical, that would be the 5th root of 81. Whoops, I made a mistake. Anybody see where my mistake was? I changed this 4 into a 5 by accident. So let's go back and fix that. So this should be a 4. This should be a 4. This should be a 4. And this should be a 4. I don't know where I got the 5 from. So this is the 4th root of 81. That makes more sense because the 4th root of 81 is 3. Okay? Although it is possible to get the other. Okay, now part 2 is we want to use these ideas to solve equations. So we want to solve equations with rational exponents. So for example, 6x to the 2/3 equals 54. So first thing we want to do is get, just like always, get the x by itself. What we would always do when we're solving equations. Our goal is to get the x by itself. So we get x to the 2/3 equals 9. Okay? Now what we want to do is we want to get rid of this exponent. So we want to make it into a 1. So we multiply by the reciprocal. So we take x to the 2/3 and we raise it to the reciprocal power, which would be 3/2. But like with any equation, if I do something to one side, I have to do exactly the same thing to the other side. When I multiply these two together, I just get x. And then I'm going to do what this says to do. So that says the square root of 9 cubed. Square root of 9 is 3. 3 cubed is 27. So x equals 27 is the correct answer. Okay? Example 2. T minus 4 raised to the 2/5 minus 3 equals 1. Okay? So in this one's slightly different because t is part of binomial. So what we want to do first is get all of this by itself. So we're going to move the 3 to the other side. So we have t minus 4 to the 2/5 equals 4. Now that we have that isolated, we want to get rid of this exponent. So we want to make that exponent into a 1. So we multiply both sides of the equation by the reciprocal. So that's 5 over 2. This is 5 over 2. So these multiplied together just give me 1. So that's t minus 4 equals, and this says the square root of 4 to the 5th power. So I get t minus 4 equals 32. And now I'm going to add 4 to both sides. So t equals 36. Okay, and let's do one more example. So that was example 2. Example 3. So if I have 5x to the negative 3/2 equals 40. Step number 1, get this by itself. So divide by 5. So x to the negative 3/2 equals 8. Now we want to make this exponent into a 1. So we're going to raise both sides to the reciprocal. The reciprocal would be negative 2 over 3. So this is going to be negative 2 over 3. These two multiply together to give us 1. And then this is the cube root of 8 to the negative 2. Cube root of 8 is 2. So that's going to be 2 to the negative 2. which is 1 over 2 squared, or 1/4. So our solution is 1/4.